Hi, now we continue our learning with the integration of inverse trigonometric functions. The integration formula of inverse trigonometric functions. So, in the previous video, you have learned about the derivative of the inverse trigo, which results in a fraction in terms of like this. Therefore, the antiderivative of that fraction will result in the form of the inverse trigonometric function. As you can see, in the future, if you find a question or a fraction that need to be integrated, and you find that there is no variable of u in the numerator, and at the denominator it is u squared. Okay, and for certain cases it has u at the front, then you know that. And another thing is, at the front of this, or another variable involved, if is a constant, this is constant, and sometimes it involves square root or without square root, then you may want to consider the inverse trigonometric functions. So u is a variable, and a here is constant. So the fraction of this, where 1 over square root of a squared minus u squared, will result in the inverse trigonometry of u over a plus c. So u will be the variable, and a is the constant of this. Three integrations formulas, which is inverse sine, inverse tangent, and inverse secant. How about another three inverse trigonometric? Actually, there are 6 inverse trigonometric functions. However, only 3 of these are noted in the rule of integration formulas for the inverse trigonometric functions, because the remaining 3 are negative versions of the ones we use. So the only difference is whether the integrand is positive or negative. So rather than we use 3 more formulas, if the integrand is negative, we can just simply factor out -1 and evaluate the integral using one of the formulas that are provided in the previous slide. Let us try these two examples. Evaluate the following integrals of a and b. Now let us try the first example. Okay, we have the integration of 5 over 1 minus x squared square root dx. So from the integration formula, if we can see, it follows the first formula, where it involves du over square root of a squared minus u squared. So for our example, a represented as 1 and u is represented as x. So the final answer will be in terms of arcsine or inverse sine of u over a plus c. Okay, now let us try this integration. So we have here a is equals to 1 and u is equals to x. So the integration of 5 over square root of 1 minus x squared of dx will be equals to, so we can take 5 out, and we have dx over square root of 1 minus x squared. So if we integrate this in this form, we will have the inverse sine of u, where u is x and a is equals to 1 plus c. So we have in terms of 5 arcsine of x plus c. So this is the final answer for this example. The next question is the integration of 3 over 4 minus x squared dx, square root of 4 minus x squared dx. So still this is the same as the previous question, where it involved the first formula, which will result in the inverse sign of u over a. So from this we have our a square is equals to 4. So a will be equals to 2. And our u is equals to x. So if we rewrite the questions, we have 3 integrate with dx over square root of 4 minus x squared, where this is the sign of u, which is x, over a is 2 plus c. So this is the final answer of the integration. Now I want you to try these exercises. You can pause this video, and once you have finished all the questions, then you can play the video and check either the solution is correct or wrong. Now let us try the first question. Okay. The integration of 1 over 2 plus 9x squared dx. These questions does not involve the square root, so this is not the solution, and this is also not the solution for this integration. So at the end of the solution, you should get the arctangent. So it is in terms of arctangent. Okay, now if you notice this formula, u square, the constant for u square must be always 1. But for these questions, it is 9x squared. So what we have to do is, we must make sure that our x squared is equals to 1. In order to do that, we have to factorize 9 out. Then we can get x squared as 1. So this will be equals to the integration of 1. So we factorize 9 out. This will be 2 over 9 plus x squared of dx. So when you multiply back this, in order to check whether you get this, whether you will get the questions back. So if you multiply back, you will get 2 plus 9x squared. So it's the same. Okay, then we take 1 over 9 out and integrate 1 over 2 over 9 plus x squared dx. Okay, here we have in terms of this form. We have here is a squared is equals to 2 over 9. So a will be equals to square root of 2 over 9, or we can write it as square root of 2 over 3. And our u is x squared. Our u is x. So if we rewrite this, you will get, so the integration of this you will get 1 over a, where a is equals to square root 2 third arctangent u is x over a, which is sec 2 over 3 plus c. This will be 1 over 9, 3 over square root of 2 arctangent square root of 3x over sec 2. This is not sec 3x plus c. So this can be simplified, and the final answer will be 1 over 3 sec 2 arctangent of 3x over sec 2 plus c. The next question is to find the integrals of 1 over square root of 5 plus 4x minus x squared. For this question, we have variable of 4x here, but in the formula there is no variable of x. We can simplify this equation by using the completing the square. Okay, first we solve the 5 plus 4x minus x squared by using the completing the square in order to simplify the algebra expressions into a simpler form. So first, I will rearrange this equation. First, I will write x squared plus 4x plus 5. And then I factorize negative out, so that is easier for me. So that the coefficients of x squared is positive 1. So we have x squared minus 4x minus 5. Then the next step is using to completing the square. So the next step is we plus the negative of b, we plus the b, where b is negative 4 over 2 square minus with negative 4 over 2 square plus c, where c is negative 5. And then this can be simplified by factorize. This will be x minus 2 square minus 4 divided by 2 will be negative 2 square is 4 minus 5. And then we solve this, we will get in terms of this one. Then we multiply negative back, we have negative x minus 2 square plus 9. Or 9 minus x minus 2 square. Okay, now we have simplified the inside equation here into this form. So we can rewrite this integration becomes 1 over square root of 9 minus x minus 2 square of dx. So you can see that This form satisfies the first formula where a squared is equals to 9 and our u here is equals to x minus 2. So I rewrite the solution back. Okay, now we have a squared which is equals to 9 and u squared is equals to x minus 2 squared. So from here, u is actually equals to x minus 2. Right, then from here, we can find the du over dx, where du is equals to 1 and we get du is equals to dx. Okay, next is solving the integration. I rewrite the question where this can be represented as dx over square root of 9 minus x minus 2 square. So our a is equals to square root of 9, which is equals to 3. So we have this in terms of du over square root of 9 minus u square, where this will be equals to the arc sine of u over a, where a is equals to 3 plus c. Our u now is equals to x minus 2. So we substitute u with x minus 2 divided by 3 plus c. So this is the solution for question E. Now let us proceed with the last question, where this integration involves the definite integral, where the interval is from 0 up to 1 over 4. So the final answer of this question will be in terms of number. Okay, first we solve without the interval first, where we have dx over square root of 1 minus 16x squared. As I said earlier, we have to make sure that the coefficient of x squared must be equals to 1. In order to do this, we have to take 16 out, but still it's in the square root. Okay, and then we have here, so in order to get back 1, we have to divide by 16 minus x squared. Okay, then we have here is the square root of 16, where this will be 4 times with the square root of 1 over 16 minus x squared. Now you can see here it is in the same formula as the first formula. The form is the same as the first formula, where you will get the arc sine. Okay, now we take 1 over 4 out, and then from here we have a square, which is 1 over 16. So our a will be square root of 1 over 16, which will be 1 over 4. Okay, so we have u is x. Our u is x, so du will be dx. So this will be arc sine of u, which is x over a, which is 1 over 4 plus c. We rearrange this we will have 1 over 4 arcsine of 4x plus c. So why we have 4x? Because x divided by 1 over 4. So this will become x times with 4. So that's why we get 4x. Okay. This is not the final solution yet, because this is in terms of the indefinite integral. Here we have the interval where the lower limit is from 0 up to 1 over 4. So in order to do this, we have to substitute x with 0 and quarter, where this will be dx square root of 1 minus 16 x squared 1 over 4 arcsine of 4x. This is from 1 quarter to 0. We have 1 over 4 arcsine of 4x, where x is 1 over 4 minus with 1 quarter arcsine of 4 times 0 is this. By using calculator, you will get pi over 8. Just for your information, how to find the inverse sine of 1 using calculator is you have to click shift and then you click sine, then you will get the arcsine, and then you click number, any number, which is for our case is 1, so you will have arcsine of 1. Then click equals, then you will get the answer.